In this video, we're just going to review a little bit more of some types of things we could be asked about volumes. So, find the area bounded from above by the function f of x equals 4 minus x squared, below by g of x equals 2, and on the left by the y-axis. So I put a graph here. What we're looking for is this area in here. Okay? So again, you kind of want to maybe reread it. We're bounding it by from above by the parabola, from below by the horizontal line, and on the left by the axis. So if this, so finding the area, I'm just going to again set up all the integrals and rely on the fact that you could do this either by hand or by or with your calculator. The integral is going to go from 0 to the square root of 2, or 1.414. The top function minus the bottom function, and that will give us the area. Now, if it were rotated around the axis, okay, so if it were rotated around the axis, it would, of course, look something like this. Okay, it would have a cylinder, hollowed out center. We'd still go from 0 to the square root of 2. But now we've got cross sections that are circles. And please remember, when we look at this, we've got a big circle and a little circle. So we've got to do the big radius pi times the big radius squared minus pi times the little radius squared. Well, I would factor the pi out, and the big radius is set by f of x, so big radius squared, minus little radius set by g of x squared dx. Okay. And again, that goes to the fact that we are doing a circle minus area of a circle minus area of a circle, and I just factored the pi out. Okay. Next, we're rotating around the line y equals -1. So y equals -1 is right here. So the only difference between this and the one above it is that I made the radius 1 unit bigger. Okay, so it's going to look very similar. It's going to have pi multiplied by the integral, 0 to square root of 2, but the big radius is going to be f of x plus 1, and the little radius is going to be g of x plus 1. Okay. And again, the reason is we made the radius 1 unit bigger by changing the axis of rotation. Okay, when we go on to the next one, if this area were the base of a solid where cross sections were in the shape of semicircles perpendicular to the x-axis. Okay, so we're building semicircles off of this. So let's just remember a semicircle. The area is 1/2 pi r squared. Okay. Now, the difference between the functions, f of x minus g of x, the distance between those two functions is the diameter. So we have to divide that by 2 to figure out what the radius is. Okay. One more time. F of x minus g of x, how far those two functions are apart, tells us the diameter. So we have to divide that distance by 2 to get what the radius is. Okay, so my integral is going to be 1/2 pi out front, integrating from 0 to the square root of 2, and then we're going to have f of x minus g of x over 2 all squared, because we need it to be 1/2 pi r squared. Okay. All right, last question. If this were rotated around the line x equals 3. Well, let me put in one more graph here so I can actually draw that. So x equals 3 is right here. So if I rotated it, I'd end up with something like this. Okay. So it would rotate around. Try and draw it three-dimensionally here, my little cylinder. Like that. So it would be dy now, the height. So I guess the first thing I would notice is that the big radius is just 3. So we'd have our pi, we'd integrate. Big radius would just be 3. Minus, so 3 squared, pi r squared. The little radius, so this distance right here, well, we're going to need to solve, 4 minus x squared, we're going to need to get an x equals out of that. So if I have y equals 4 minus x squared, I could manipulate this to be x equals the square root of 4 minus y. You might want to check that and make sure you can see how we got that, but that would be this function, as a function of y instead of x. Now, we're looking for the distance between 3 and that function. Remember, a function always tells us how far from the axis we are, so we'd have to do 3 minus the square root of 4 minus y squared. So again, we'd have pi r squared minus pi r squared. The big radius is 3. The little radius is the difference between 3 and the function. And our bounds on this, well, it's in terms of y, so they would go from 2 to 4.